In our previous lecture, we discussed with you the various laws of chemical combination. Today, we'll try to illustrate all those laws through certain numerical problems. What were the various laws? Laws of chemical combination laws were law of conservation of mass, law of constant or the definite proportion, law of multiple proportion, law of reciprocal proportion, and the Gay-Lussac's law of a combining volume. Now today, we'll try to solve the problems based on these laws. Certain questions are written over here on the board based on law of conservation of mass, law of multiple proportion, law of constant proportion, and the Gay-Lussac's law. The numerical problem of reciprocal proportion are not to be done. Now question number 1. What mass of sodium chloride would be decomposed by 9.8 gram of sulfuric acid? If you take sodium chloride and sulfuric acid. So sodium chloride, when made to react with sulfuric acid, it will result in the formation of sodium bisulfate and HCl. What mass of sodium chloride would be decomposed by 9.8 gram of sulfuric acid? What is the mass of sulfuric acid given? 9.8 gram. If 12 gram of sodium bisulfate, what mass of this is formed? 12 gram of sodium bisulfate and 2.75 gram of hydrogen chloride are produced. I think I must be very clear. What is the question given? It is given certain mass of NaCl react with H2SO4 to form 12 gram of sodium bisulfate and 2.75 gram of HCl. So, what mass of sodium chloride would be decomposed? Let this mass over here will be X gram. So, which law will be applied? Law of conservation of mass. According to the law of conservation of mass, total mass of the reactant will be equal to the total mass of the product. How will we solve it up? The concept is the total mass of a reactant. This over here will be equal to the total mass of product. Total mass of a reactant will be equal to the total mass of a product. How will we solve it up? This will be X plus 9.8 will be equal to 12 plus 2.75. Fine. If you solve it up, what will be the value of X coming? So X plus 9.8 will be equal to 14.75. You solve for the value of X over here and get the desired answer. So what will be the value of X over here? X will be equal to 4.95. Am I clear? This will be equal to 4.95. So, which law is being followed to solve this numerical problem? Law of conservation of mass, in which the total mass of a reactant is equal to the total mass of the product. Now, let us come to the question number 2. Carbon combines with hydrogen to form 3 compounds A, B and C. In the question, we are given with 3 compounds. These are compounds. Which are these compounds? A, then B, and then C. We have got the compound A, B, C. The percentage of hydrogen in A, B, and C are. If you find out the percentage of hydrogen in A, B, and C are. In A, this is 25%. In B, it is 14.3%. And in C it will be 7.7%. which law of chemical combination is illustrated? It is a hydrocarbon. This is hydrocarbon. So percentage of hydrogen. So we find out the percentage of carbon in each case. This will be 100 minus 25. It will be equal to 75. This over here will be 100 minus 14.3. And this will be 100 minus 7.7. Find out this one. This will come out to be equal to 85.7 and this will come to be equal to 94.3. Fine. So what will be this value? This will be 85.7. And this value 92.3. I think I must be very clear. Yes? In this hydrocarbon, we have got with you the percentage of hydrogen, percentage of carbon. Now, we have to prove with these data what laws of chemical combination is proved. If it is following a law of multiple proportion, then remember the definition. Mass of one element is to be fixed, and from that fixed mass, the mass of other element is to be determined. If it comes in the simple multiple ratio, then the law of multiple proportion will be proved. Let me solve it up. Suppose we have a part A. In the part A, 25 parts by mass of hydrogen combines with what? 75 parts by mass of carbon. So 25 part by mass of hydrogen combines with 75 part by mass of carbon by mass of carbon. Yes? If I fix the mass of hydrogen, if it is 1, it will be 75 divided by 25 and will come to be equal to 3 parts of carbon. Is it clear? Remember over here, what mass of hydrogen I have fixed over here? 1. Now if I take part B, in part B, if mass of hydrogen is 14.3, what is the mass of carbon? 85.7. So 14.3 parts of hydrogen combines with 14.3 part of hydrogen combines with 85.7 part of carbon with 85.7 part of carbon. 1, let me fix the mass 1. Here I took the mass 1. So I am taking the mass 1 as a fixed mass of hydrogen. If I take this as 1, it will be 85.7 divided by 14.3. And what will be this mass coming? It will be coming 6 part of carbon. I think I shall be very clear. I fix the mass of a hydrogen and is calculating the mass of a carbon. Then part C. If I take 7.7 part by mass of hydrogen, it combined with what part by mass of carbon? 92.3. 7.7 part of hydrogen combines with 92.3 part by mass of carbon combines with 92.3 part by mass of carbon. Mass of carbon. So if I fix the mass to 1 part, it will be how much? It will be 92.3 divided by 7.7. what it will come to be? It will come to be equal to 12 part by mass of carbon. So mass of hydrogen is fixed. So ratio, you find out the ratio of mass of carbon. This will be 3 ratio 6 ratio 12. What is the answer coming? 1 ratio 2 ratio 4. Is it a multiple ratio? Yes. So which law is illustrated? The law of a multiple proportion. Here the mass of carbon is, hydrogen is fixed to 1 gram. From that mass, the mass of carbon is calculated and the ratio comes to be 1:2:4, which is a multiple ratio. So which law is illustrated by this? Over here, this is the law of multiple proportion. So which law is illustrated? Law of multiple proportion. So in this case, the law of multiple proportion is illustrated. I think I shall be very, very clear. Fix the mass of one element. You may fix it any value, 1, 100, 1000, anything. Calculate the mass of other element. If it comes to be a simple multiple ratio, then the law of multiple proportion is proved. Now, let us solve question number 3. In the first two questions, we have established the law of conservation of mass and the law of multiple proportion. In question number 3, just read the question. In an experiment, 2.4 gram of iron oxide on reduction with hydrogen, it gives 1.68 gram of iron. And in another experiment, let me solve it up. If you take experiment 1, what is this? We have iron oxide. When reduced with hydrogen, it will result in the formation of iron. 2.4 gram of iron oxide. What is the mass of iron oxide? 2.4 gram. On reduction with hydrogen gives 1.68 gram of iron. Now if I take another experiment, in experiment 2, what is given? 2.9 gram of iron oxide give 2.03 gram of iron on reduction. So another experiment will be, if I take iron oxide when reduced with hydrogen, it will give iron. Fine. What is the mass of iron oxide given over here? 2.9 gram. Just see over here. And what mass of iron is obtained on reduction with hydrogen? 2.03 gram. The question is, show that these data illustrate the law of constant proportion. What is the law of constant proportion? When two different elements combines to form two or more than two different compounds, then masses in which they do so will always be in the same ratio, no matter from what source they are obtained. So over here, the compound is iron oxide. So what we will do? We'll find out the ratio between iron and oxygen. Here again, we'll find out the ratio between iron and oxygen. If it comes to be same, then the law of constant proportion will be proved. What is the mass of iron over here? 2.4. What is the mass of iron oxide? 2.4. What is the mass of iron? 1.68. So find out the mass of oxygen. Mass of oxygen. What will be the mass of oxygen? Iron oxide mass minus 1.68. This will be equal to 0.72 gram. What is the mass of iron? 1.68. So ratio between oxygen and iron, it will be 0.72. This will be ratio 1.68. If I solve it up, it will come to be equal to 1 ratio 2.33. Now if I look at another experiment, Here mass of iron oxide is 2.9 gram, mass of iron is 2.03. So find out the mass of oxygen. What will be the value coming over here? It will be equal to 2.9 minus 2.03. What value will be obtained over here? This will be equal to 0.87 gram. Fine. So what will be the ratio between oxygen and iron? Oxygen is 0.87 and iron is 2.03. What is the ratio coming? 1:2.33. Just see this ratio and this ratio. Are the ratio coming to be same? Yes. Since the ratio in both these cases are same, so what law will be established? Law of constant proportion. So over here, the law of constant proportion is proved. So we established the law, which is a law of constant proportion. Is it clear to everyone? Yes. Find out the ratio of both the element, iron and oxygen, in both the experimentation. If it comes to be same, then the law of constant proportion is proved. In the multiple ratio, it was coming as a simple ratio. I think the three questions must be very, very clear. Now look at question number 4. This is something what you have done in the class 10th also, Gay-Lussac's law. How much volume of oxygen will be required for complete combustion of 40 ml of acetylene? If you burn acetylene with oxygen, how much volume of oxygen will be required to burn 40 ml of acetylene? How much it is given? 40 ml. To burn 40 ml of it, what volume of oxygen is required and how much volume of carbon dioxide will be obtained? All volumes are measured at normal temperature and pressure. What is Gay-Lussac's law? When the gases react, they react in the simple ratio of their volume. And if the product is also in the gaseous state, it also bear a simple ratio to the volume of the reactant, provided the temperature and pressure does not change. Now, just see over here, in Gay-Lussac's law, how many volume over here? 2 volume. To burn 2 volume of acetylene, what volume of oxygen is required? 5 volume of oxygen is required. I think I shall be clear. To burn 2 volume of acetylene, class 10th problem, 5 volume of oxygen is required. So to burn 1 volume, what is required? 5/2 volume of oxygen. What is the volume of acetylene given over here? 40. So to burn 40 ml, what is required? 5/2 into 40. You solve it up and it will come to be equal to 100 ml. I think I shall be very clear. To burn 2 volume of acetylene, what volume of oxygen is required? 5. 5/2. And to burn 40, so it will be 100 ml. Now, second is, what volume of carbon dioxide is produced? If 2 volume of acetylene is burned, what volume of carbon dioxide is produced? 4 volume. Volume relationship, the class 10 problem. So when a 2 volume of acetylene is burned, when 2 volume of acetylene is burnt, 4 volume of carbon dioxide is produced. 4 volume of carbon dioxide is produced. If 1 is burned, it will be 4/2. And if 40 volume is burned, 40 ml is burned, what volume of it will be produced? 4/2 into 40. Answer will be 80 ml. So it will produce 80 ml of carbon dioxide. I think all these problems must be very, very clear. Am I clear? So today we have done certain numerical problems based on the laws of chemical combination. In our next lecture, we will proceed ahead with the chapter. By that time, you are expected to solve the problem from the book. Thank you.